Welcome to our channel MooTechie. This series focuses on the contributions of scientists in microbiology, exam-oriented and high-yield, perfect for your review. Let's begin with a course overview. We'll take a journey through the history of microbiology, highlighting the pioneers who revealed the invisible world. This overview is designed to be minimalistic and high-yield for exam preparation, with a visual focus on key portraits and discoveries, all presented with consistent MooTechie branding. Now, let's meet Antony van Leeuwenhoek, who lived from 1632 to 1723. He is known as the father of microbiology for his pioneering work with microscopes. He was the first to observe and describe bacteria and protozoa, which he called animalcules. Leeuwenhoek crafted superior single-lens microscopes capable of magnifying up to about 300 times. He also documented microbial life in rainwater, plaque, and blood through meticulous drawings. His work opened our eyes to a world we couldn't see before. Next, we have Louis Pasteur from 1822 to 1895. He proved the germ theory of disease, fundamentally changing medicine. Pasteur's famous swan neck flask experiments disproved spontaneous generation. He invented pasteurization to kill spoilage microbes in milk and wine, and he developed pioneering vaccines for rabies and anthrax. Pasteur showed us that microbes cause disease and taught us how to control them. Moving on to John Tyndall, 1820 to 1893. He demonstrated that dust carries microbes, providing crucial optical proof supporting Pasteur's germ theory. Tyndall developed Tyndallization, a fractional sterilization method to kill heat-resistant bacterial spores. He also explained endospore heat resistance, solving issues of persistent contamination. And he designed the Tyndall box to prove that optically pure air does not cause broth decay. Tyndall's work helped solidify the scientific basis of germ theory. Now, let's discuss Joseph Lister, 1827 to 1912. He introduced antiseptic surgery using carbolic acid or phenol to sterilize instruments. This dramatically reduced post-operative infections and surgical mortality rates. Lister advanced hospital aseptic techniques and modern wound care protocols. He is revered as the father of modern surgery for making operations safe. His practices are the reason surgeries today are much cleaner and safer. Here we have Robert Koch, 1843 to 1910. He established Koch's postulates, the gold standard for linking a specific microbe to a disease. Koch identified the causative agents of deadly diseases, anthrax, tuberculosis, and cholera. He pioneered techniques for pure culture using solid media like agar to isolate bacteria. And he developed advanced staining methods essential for visualizing bacteria under microscopes. Koch gave us the tools to pinpoint the exact microbes behind infectious diseases. Now, let's look at Edward Jenner, 1749 to 1823. He developed the world's first vaccine using cowpox to prevent smallpox. Jenner demonstrated cross-protection, proving that milder infections could impart durable immunity. He laid the essential foundation for the field of immunology and preventive medicine. His work ultimately led to the global eradication of smallpox in 1980. Jenner's insights saved countless lives and launched the era of vaccination. In this slide, we meet Alexander Fleming, 1881 to 1955. He once said, "I did not invent penicillin. Nature did that. I only discovered it by accident." Fleming discovered penicillin in 1928 from Penicillium mold, the world's first true antibiotic. He revealed its potent antibacterial action against Staphylococcus, launching the antibiotic era. He also discovered lysozyme in 1922, an antimicrobial enzyme found in tears and saliva. And he warned early about antibiotic resistance, urging prudent use of these life-saving drugs. Fleming's accidental finding changed medicine forever. Now, let's explore the overall impact of these pioneers on microbiology. From invisible discoveries to global health revolutions, they transformed our world. The discovery of penicillin launched the antibiotic era, turning once fatal bacterial infections into treatable conditions. Germ theory established that specific microbes cause specific diseases, replacing superstition with science. Standardization brought essential lab techniques like pure culture methods, solid media, staining, and high-power microscopy. Vaccination revolutionized immunology, starting with smallpox, laying the foundation for modern preventive medicine. And public health was transformed through aseptic surgery, sterilization, and pasteurization, drastically reducing mortality rates. Together, these advances built the foundation of modern microbiology and medicine. Thank you. Stay tuned for more microbiology insights. If you have questions, connect with MooTechie. We hope this overview helped you see the incredible legacy of these scientific pioneers. Keep exploring and remember, every big discovery starts with curiosity.